afternoon, everyone. My name is Hassan, and today I'll talk to you about my third year project, the multiple choice exam generator, or as I like to call it, Megan. The plan for today's talk is as follows. I'll start off with a bit of overview, followed by the development methodology that I'll be using, which consists of four main phases: requirements gathering, analysis and design, implementation, and testing. And just before I conclude, I'll give a short demonstration of how the exam generation process works. So let's make a start. As I've already mentioned, Megan is a multiple choice exam generator. It's aimed at lecturers here in the School of Computer Science. And what it hopes to achieve is to simplify the process of exam generation. So what lecturers typically do when they generate this type of exam, or when they write this type of exam, is that they have to come up with questions, either at the time of writing the exam, or by looking at past exam papers, or by having some sort of a library or a database where they have the questions, and then they pick the questions that they want to use and use it in the exam. But as you can see, this is not an organized process, and different lecturers will have different ways of going about it. So what Megan hopes to achieve is to organize this process so that all the questions and exams will be in one secure place where it's easier to manage. The output of the exam generation process is going to be a LaTeX document which follows the same style and structure of computer science exams. And as you can see from the figure in front of you, we have three main components for the system. The add question component, where users add questions. The generate exam component, where they generate exams from the list of questions that they have. And once they've generated exams, they can view them, compile them, or even download them if they want to. The next thing I'd like to talk about is the development methodology that I'll be using. So I'll be using an iterative development methodology, which breaks the workload into small and manageable pieces, where we can iterate over them over and over again. It consists mainly of four phases. The first one is requirements gathering, followed by analysis and design, and then implementation, and finally testing. Now this might seem as a sequential process, but it's not. So let's say at some point we are in the implementation phase, and then we figure out that the design we had is not that good. So we go back to the design phase, come up with a new design, and then go back to the implementation process, and so on. What I need to do next is talk about each one of these phases in more details, starting off with the requirements phase. So requirements gathering is an ongoing process. It's not something that you do at the very beginning of your project and then forget about in the middle of the development cycle. No, you get some requirements at the beginning of the project and keep gathering requirements as you go on in your development cycle and update your requirements document. But from the current list of requirements that I've got, I can identify four main categories. Authentication and authorization is the first category. So I've mentioned that this is for lecturers here in the School of Computer Science. So what we want them to do is to authenticate themselves in order to use the system. And ideally, we want them to do this using the university's central authentication system. And in order to prove that they are from the school in here, we have to use some sort of a whitelist of usernames who are allowed to use the system. This whitelist is going to be maintained by a system administrator. The next category is the questions management. So users must be allowed to add questions to the courses that they've been assigned to. And they can specify the question itself using LaTeX syntax. They can assign it a difficulty. They can assign different options to it, and which one of the options is the correct one. This is going to be useful in generating marking schemes later on. And they can also add images to the question if they want to. And once they've added a question, they can view it later on, they can edit it, they can delete it if they wish to do so as well. The third category is the exams management category, where users are allowed to generate exams from the list of questions that they've added. And once they've generated an exam, they can as well edit the source code. I've mentioned it's a LaTeX document, so they can edit it. They can also compile it online, and if they wish to, they can download it. So I'd like to talk about the process of compiling documents online, LaTeX documents. So in order to do this, we have to use something known as CLSI, which is shown in the figure in front of you. CLSI stands for the Common LaTeX Service Interface, which is basically a set of tools that allows us to compile documents online. So the way it works is that we have the application, sends a compile request to that server, which is a local server. The server would process the request and see if we need to obtain any sort of resources or images. If so, we'll ask the appropriate file server for those images and download them. Once we have everything set up, we can compile the document and return the result back to the application. So that's how it works simply. Then the last category we have is application management. So we have two different types of users. We have normal users or lecturers who can add questions, generate exams, and so on. And we have also system administrators whose job is to manage the application as a whole. So they will be responsible for managing users, responsible for managing courses, and they can also view other users' exams and questions. The next phase we've got is the analysis and design phase. So once we have a set of requirements, we can start by analyzing them and coming up with a design that fulfills those requirements. Now this is a very important step in this project since security is a big issue. If the system gets compromised, we have exam questions will get compromised, and we don't want that to happen. So what we want to do is to be careful when we design our algorithms and the system as a whole in order to avoid any type of security flaws or loopholes. And to demonstrate how important is this step, I'll be talking about a rejected design for the authentication system. So I've mentioned that we're authenticating users against the university's central authentication system. And to do so, we use something known as LDAP, which stands for Lightweight Directory Access Protocol. And if you're not familiar with it, the way it works simply is that you just give it user credentials and it tells you that they're valid or not. That's how it works in simple terms. But in order to do so, the request has to originate from within the university network. But since my application is not hosted here in the university, I had to come up with this design to overcome this problem. So what will happen is that my application will send a request to the computer science server, which is my personal web space in here, where I have an application whose job is to take those details, pass them to the LDAP server, get the results back, and send them back to the application. Now it might seem as a feasible solution, but we have a security problem in here. The computer science web server is not secure. It doesn't use secure communication, doesn't encrypt traffic. Whereas my application and the LDAP server are both secure and they both use secure communication. So if someone, like an attacker, decides to implement some sort of sniffing mechanism on the computer science web server, which is on my web space, the user's details might get compromised. So I had to reject this design and come up with an alternative design to authenticate users. Now, before I move on to talk about the implementation phase, I'd like to talk a bit about the software architecture that I'm using. So I'll be using a model view controller software architecture pattern, which is a form of client-server architecture. What this allows us to do is separate the view from the business logic. So we have a separation of responsibilities. Each class would have its own responsibility. So for example, the view would be responsible for representing the user information to the user. And the way I'm implementing this is in my system is as follows. So you have the user, for example, adding a question. So he fills in a form, submits it to the controller. The controller will call in the appropriate model, which would update the database and send the result back to the controller. Depending on the results returned, the controller would call the appropriate view and dispatch it to the user. Now the reason I've decided to go with MVC is because it makes it easier to maintain code in large projects. This means that, for example, we need to edit the view, we need to change the view. We can do so without affecting the other components. It makes it easier to test the code as well because we have different responsibilities and therefore we can apply unit tests to each class separately. It's also easier, it makes it easier to reuse the code So for example, we decide to have two different views for the add question component. We can do so and use only one model instead of rewriting the model for each view. So now we can talk about implementation. Implementation is just a realization of the design that we came up with in the previous step. So if we have a pseudocode for an algorithm, what implementation will do is just convert it into an actual working software. The technologies that I'll be using include PHP and MySQL for the backend, where most of the work would happen. HTML, CSS, and jQuery will be used for the front end, which is the user interface. And I'll also be using some third-party tools, such as CLSI, which I've mentioned before. ACE, which is an online source code editor with syntax highlighting for LaTeX. And also PDF.js, which is a native PDF viewer built entirely in JavaScript. Now I won't be using these libraries as they are, because I need to make some changes to them in order to work the way I want them to work in this project. The implementation that I'm planning to do is going to start from the back end. So I'll start building these small functions and go up all the way till I have a fully working backend for a piece of the software. And then that can be tested. And once we're satisfied with the testing results, we can start building the front end later on. The last step in my development methodology is the testing phase. It's as well an important step because security, as I've mentioned before, is a big issue here. And the way I plan to do testing is to have two types of testing. I'll have unit testing, where I'll be testing small components of the software, like separate functions or separate classes altogether. And this would be done using PHP. I'll also be doing integration testing, a bottom-up integration testing, where we integrate two functions at a time and start testing them until we test the whole application as a whole, as shown on the figure in front of you. So the next thing that I'd like to do is to show you a small demonstration of how the exam generation process works. So we need to make two assumptions here, that the user has already logged in, so he's authenticated and authorized. He has already added some questions to the database. The way it will work is that he has to provide some details for the exam that he wants to generate. So stuff like the course that he wants to generate the exam for and the date. And if he wants to, he can add some optional information like any special information, exam rubrics, whether calculators are allowed or not, and then he can move on to the next page. And the next page, he would specify which type of exam this is. Is it mock exam? Is it a reset exam? He would specify the number of questions that he'd like to generate and whether he wants to select them randomly or he wants to specify all his questions. So for this demonstration, we'll go with random question selection. The last page is a summary of what the user has already entered, and it shows him a list of the questions that were selected for him, where he can sort them if he wants to by difficulty, for example, ascending order of difficulty. And if he's not happy with it, he can generate another set of random questions. And once he's satisfied with the result, he can click the generate button, magic happens, and a LaTeX document is generated where he can view that exam, compile it, download it, and so on. So that's simply how the exam generation process works. So to sum up, I've mentioned that Megan is a multiple choice exam generator aimed at lecturers here in the School of Computer Science. What it hopes to achieve is to simplify the process of generating this type of exam. I'll be using an iterative development methodology, which breaks down the workload into smaller manageable pieces and iterates over them. It consists of four main phases: requirements gathering, analysis and design, implementation, and finally testing. And since the application has to be secure, we have to think carefully in the way we design our algorithms and the system as a whole. I'll be using a model view controller architecture pattern, which makes it easier to maintain the code, test it, and reuse it. And as far as testing is concerned, I'll be doing two types of testing: unit testing and a bottom-up integration testing. So this concludes my talk for today, and if you have any questions, please feel free to ask.
Where have you got to in your work?
I have a fully working prototype now, but I still have many features to add as well. Like we have a social bit where lecturers doing the same course can collaborate on editing their exams. I'm also thinking of encrypting the database as well in order to increase security. Basically, I have a fully working prototype now.
Your main technical challenges have been or are?
What do you mean?
What's the technical challenge in your work?
And the technical challenges, well, managing such a large project was a big challenge. Like you have to put all these pieces together and make them work together without confliction. And I've also mentioned that the libraries that I'm using are not the way that they are built are not suitable for me to use them. So I had to edit most of them in order to work in this project. And also security. Security is a big issue, as I've mentioned. You don't want to compromise user details or the exam questions. So I had to think carefully of the way I implement my system in order to be secure. So this included securing the sessions, generating one-time tokens for the users to use, and as I've mentioned, I'm planning to do encryption, database encryption as well.
You mentioned the computer science website was not secure, and you'd addressed that. You didn't really go into detail on that.
Yeah, because I didn't